go back and do figure 10. It's an easier one. I'll let you do that one. And then figure, let's do figure 13. It's kind of a harder one. I'll let you kind of work on figure 12 here. So same idea. We might have to add extra lines here for our time. In this case, F and D are basaltic dikes. So they're dikes. So again, a dike is an intrusion that's discordant, right? Not concordant. So it's going to be intrusive. So the dikes are going to have bake zones on both sides. So F and D. So let's put the hornfells. Whoops. Let's do it like that. Hornfells on both sides, right? And since D is cutting across F, it's going to have hornfells like this, right? On both sides. So in other words, when D and F intruded, it burned the adjacent rock, right? So that's a hornfels facies metamorphism. All right, so we'll add those in there. Those are both intrusions that came after these units were deposited. We got some folded rock here, and it looks like G, in fact, we'll put another layer down here because I think I need extra ones. G is going to be the oldest one here. G is the oldest unit. And then looks like based on superposition, it's going to be J and C. So we'll put J and C. And then we're going to have some folding event. Putting the folding event here because these D and J D and F are not folded like these other strata. So the folding event must have occurred before the intrusion of these basalt dikes, D and F. So now what's the next unit that's going to be? So it has to be F, and that's the dike. I know it's F because D is younger than F because it cuts across this, and also this unconformity is going to be younger, but D is going to be younger than that unconformity. In fact, D is going to be younger than E because it's going all the way up there. All right, so after F here, this intrusion, we're going to have this erosion, right? Because I see the erosion happening right there. And note that these layers, I, E, and B, are at a different angle than J, G, and C. So that's going to be an angular unconformity. Put U and C for unconformity. So that's the angular unconformity right there. Okay, so we just documented that. And then I see, based on the principle of inclusions, pieces of older rock, C and J, and even maybe some F included in B. So B is going to be the next younger unit based on the principle of inclusions and also the fact that it's on top, right? And then I'm going to have E. But then the next thing, C, I'm going to have this intrusion D come in here. So D is another dike because it doesn't intrude I. So I is going to be an event that occurs later on after the intrusion of D here. And then now I have another unconformity right here, right? And that's going to be another angular U and C, unconformity. And the last two units I have are H and A. There, I completed that whole sequence. So I'll let you do figure 12 here. Okay, the next section here is on fossil succession. And this is an important part of the lab because we're going to be dealing with these index fossils and fossil range zones or fossil age ranges. Key thing about index fossils, they have to follow these three criteria. Wide distribution, easy to identify, lived over a short duration of time, right? So read about this, and then you'll see there's a couple of questions regarding this idea of widespread distribution and short duration. And you can kind of pick the answers for these two, for A, B, and C. I'll let you work on this on your own. This for activity 1.6. This next activity, which follows 1.6, is going to be more on these index fossils. And I want to get to the Brachiopods in a moment here, but read about what's going on here. Sedgwick and Murchison, they had the great battle of the Silurian, Ordovician, and Cambrian. But let's look at this geologic column, right? So these lines represent the age ranges or the range zones, right? So trilobites as a whole lived throughout the Paleozoic, right? From Cambrian, they went extinct at the end of the Permian. Amphibians really started in the Devonian, and they're still around today. So they have a very widespread range zone. And over here, I talk about, yes, trilobites, reptiles, fish have very long ranges. But if I had a rock that contained trilobite, fish, and reptiles, I could use the range zones to narrow down the age. And so, for example, so if I had trilobites here, if I had fish and reptiles, well, I cannot start my timeline, my age, until I get reptiles. So that would be sort of the base of my age. The oldest it could be would be Pennsylvanian, right? Kind of the late Pennsylvanian. But then I see that trilobites do go extinct here at the end of the Permian. So the youngest this rock can be that would have all three would be Permian, right? So this zone in here, if I can sort of shade it in here, this zone includes fish, includes the trilobites, and it includes the reptiles. So you have to include all three of the species found in your rock, right? And now I've narrowed down the age. So we're going to use something like that to help us with the Paleozoic Brachiopods, this overlapping age ranges. And on the exam, I have several questions that deal with overlapping age ranges, and you can narrow down the ages. So in this case, we're saying it's Pennsylvanian Permian, but you can see it's also, let's say it's going, so maybe it's like 310 to 251. So you can actually narrow this down with numerical ages as well, right? 310 to 251. That would be the age of that rock with those three fossils in it. All right, so here are the bunch of brachiopods, right? So based on these overlapping age ranges, we're going to determine the age of the rock. And so here are the ranges of these fossils. For example, let's look at Macrospifera, which is a very good index fossil because it has a very short duration. Only lived in the late Devonian and a little bit into the Mississippian, right? So it has a very short duration. Based on the overlaps in their age ranges, what brachiopod fossil assemblage would indicate a Permian age? So what assemblage? So one that would have this fossil, right? A Permian age, you would have to, so Contes, so we can pick Contes here. We'll put Contes. Also, we could have Neurospifera, right? This guy down here, well, so what I'm looking at here, we'd have Contes, we'd have this Neurospifera, right? So let's put that one here, Neospifera. So you can just put two there, right? Contes, Neurospifera, two. You could also pick Petrocrania. Here's another one because it goes into the Permian, and Schizophoria, which is another one that goes into the Permian, right? I guess you could pick this Cleotheridina, but it's only partly into the Permian. But certainly these three cover the entire Permian, right? So that's one thing. So you can do the same thing for Silurian. Pick any two or three brachiopods that would be Silurian in age. Do the same thing for Ordovician. So just go over here and pick some of these that fill in the right time period, either Ordovician or Silurian. Now, for part B, apply the overlapping age ranges to the geologic time puzzle cross-section in figure 10. So if we go back to figure 10, so here's our figure 10, right? So if Neurospifera is found in unit D, so where is unit D? So I'll put NEO for Neospifera here. And then Platystrophia in F, and F, I'll put Platy in F, Platystrophia, and Strophomenia in A. I'll put Stroph here for A. Suggest age range for unit C. Explain your answer, right? All right, so Strophomenia, if we go back over here, in fact, we can look at it this way. So Strophomenia here, Strophomenia has a very short duration, so it's a good index fossil. So it's only a mid to late Ordovician. So this would be mid to late Ordovician. That's already figured that one out. What about Platystrophia? Platystrophia is, that's late Ordovician to mid Silurian. So this is, we'll put late Ordovician to mid Silurian. And then Neospifera here is, what's the age of Neospifera? That's way up here. That's Pennsylvanian to Permian. So I'll put PENN to PER for Permian, right? So those are the ages. So they're asking us now the age for unit C. So So unit C is so unit C is older, right? Because that's Ordovician Silurian. This is Ordovician. So all we can say here it's that it's older than mid Ordovician. That's all we can say, because we have nothing to bracket this unit underneath there, right? So it could be Cambrian, it could be Precambrian. We don't know, right? But all we know, it's older, right? Because we have nothing to bracket it on the bottom. So what is the extent of the gap in geologic time record represented by the angular unconformity below unit D? So here we have the angular unconformity, right? So there's the angular unconformity. So how much? So we know this guy is late Ordovician to mid Silurian, right? And then this is Pennsylvanian Permian. So what are we missing? So we're missing, this ends Ordovician. So we're missing the Devonian, Mississippian, and part of the Pennsylvanian, right? So we're missing these, you know, the Devonian, Mississippian, and early Pennsylvanian. So we'll say something like that. So we're missing Devonian, Mississippian, and early Pennsylvanian, right? So we just write it like that. So you can see what I'm doing there. I'm just kind of using these brackets. I guess if we wanted to actually put a number on there, you know, we're missing. So if we're going, so this Platystrophia goes to mid-Silurian, right? So mid-Silurian would be right in here. So let's say that's maybe about 425, and we're going to Pennsylvania. Let's look at that Neospifera there. Yeah, so on our, what I just answered over here, we wouldn't have the Pennsylvanian there, right? Because this starts at Pennsylvania there. And so which means on our time over here, we're going right to 318. So we're basically, the age would go from 425 to 318. So that would be the gap that would be missing there. So 325 to 318. That's the time gap we're seeing at that angular unconformity right there. All right, so now for figure 11. So for this figure 11, you're going to flip this over. This is one we did together. You'll do the same thing, right? You'll see that all these units have different brachiopods. You'll use the age ranges to label those units just like I did earlier, and then you can answer the rest of these questions. So I did figure 10. Your job is to do figure 11. Figure that out, okay? So that's something that I'll check when I grade the lab there.